14 date, exercise 5.1, 30 number 2 example. Okay, example number 30. Find the value of a and b such that the function defined by f of x is equal to 5, where x is less than equal to 2, ax plus b, where 2 less than x less than 10, and 21, where x greater than equal to 10 is continuous function. Here function is continuous at which point? Okay, so that here clearly show that x is less than equal to 2 as well as x greater than 2. Okay, and x less than 10 as well as x greater than equal to 10, so that we clearly say that x is equal to 2 as well as x is equal to 10, given function is continuous function. First case, at x is equal to 2, function is continuous function, so that limit x tends to 2 minus left hand side limit as well as right hand side limit gives the same value at that point. Okay, so that limit x tends to 2 minus f of x is equal to limit x tends to 2 plus f of x, so that limit x tends to 2 minus slightly less than 2, function gives answer is equal to 5. Okay, and limit x tends to 2 plus, that means slightly greater than 2 gives the function ax plus b. Okay, so that 5 is equal to, put the x is equal to 2, 2a plus b. First equation gives that 2a plus b is equal to 5. Okay, same at x is equal to 10, given function is continuous, so that limit x tends to 10 minus f of x is equal to limit x tends to 10 plus f of x, slightly less than 10, that means the function is ax plus b. The limit x tends to 10 minus ax plus b is equal to slightly greater than 10 gives the value of 21 directly written, so that limit x tends to 10 minus ax plus b is equal to 21. Put the x is equal to 10, so that 10a plus b is equal to 21. Equation number 2, 1 minus 2 subtraction करिए तो 2a plus b is equal to 5 and 10a plus b is equal to 21. Subtraction, b cancel out, 2a minus 10a minus 8a and 5 minus 21 minus 16, so that a gives 2 value. Okay, that means k is equal to 2. From equation 1, putting a is equal to 2, so 2 to 4 plus b is equal to 5, that means b is equal to 5 minus 4, that means b is equal to 1. Okay, example number 14 and example number 15, do it yourself. Okay, example number 14 is a one type of statement. Okay, example number 14 gives that every polynomial is a continuous function. Okay, and example number 15 refer exercise 5.1 question number 19, same. Okay, so example number 14 and 15, do it yourself as a homework. Okay, next topic is algebra of continuous function. Okay, and theorem number 1. Okay, suppose f and g be two real function which is continuous at a real number c. Okay, that means ke f and g both are continuous function at any point. Okay, then and then this happen, summation of these two functions, that means ke f plus g is also is continuous at that point. Okay, that means f continuous function and as well as g continuous function, then and then its summation, that means f plus z is also continuous at x is equal to c. Same to same, second portion, it subtraction of these two function also continuous at x is equal to c. Same way, multiplication of these two function is continuous at x is equal to c, and division is continuous at x is equal to c. Okay, but division mate g of c is not equal to 0, denominator is not equal to 0, always remember this one. Okay, same unrelated example illustration, example number 16. Okay, prove that every rational function is continuous function. Okay, every rational function is a continuous function. Okay, rational function f is given by f of x is equal to p of x upon q of x. Okay, but q of x is not equal to 0. Here p of x and q of x is a polynomial function. Okay, and according to example number 14, which is one type of statement that every polynomial function is a continuous function, so that e of x is continuous as well as q of x is continuous. Okay, again theorem 1 use kariye. Theorem number 1 and a fourth statement, that means ke f and g, that means ke p and q both function are continuous function, that is division is also continuous function, so that f is a continuous function, that means ke every rational function is a continuous function. Okay, example number 17. Okay, discuss the continuity of sine function. Okay, you have to find the at point, which point given sine function is a continuous function. Okay, consider f of x is equal to sine x. Okay, let c be any real number. Okay, c belongs to R. Okay, at that point which for that function is continuous or not, you have to check. Okay, then limit x tends to c, f of x is equal to limit x tends to c sin x. Okay, put the value of c instead of x, that means the answer is equal to sin c, and direct f of c is equal to sin c, that means that these two answers same, so that limit x tends to c, f of x is equal to f of c. Okay, these are the definition of the continuous function. Okay, so that f is a continuous function at any real number. Same here, same to same, cosine function is a continuous function, same point, f of x is equal to cos x consider કરીશું આપણે. same way exercise 5.1 નો 21 example number. Okay, so 22 number નો example છે આપણી જોડે 22. Okay, 22 no example, cosine, sec, tangent. Okay, you have to prove this function is a continuous function. Do it yourself. Okay, same way example number 18, 10x, example f of x is equal to 10x. You have to prove, that means that this function is a continuous function. Okay, these two are the homework. Okay, exercise 5.1 21 number નો example. Okay, theorem 1 જોઈ લો, એના પરથી આપણે પ્રૂવ કરી શકીએ એક જ સ્ટેપ પરથી. discuss the continuity of the following function. Discuss the continuity of a following function. Okay, first one is f of x is equal to sin x plus cos x. Consider these two as a separate function. Okay, let g of x is equal to sin x and h of x is equal to cos x. Okay, c be any real number. Okay, that means the limit x tends to c, g of x is equal to limit x tends to c sin x, that means the answer will be sin c, and it is also known as a g of c. Same way limit x tends to c, h of x is equal to limit x tends to c cos x, gives the answer cos c, and it's nothing but h of c, so that we can say that g and h both function is continuous at x is equal to c, so that summation of these two functions, subtraction of these two functions, as well as multiplication of these two functions is also continuous function. Okay, so a b and c 21 ના complete થઈ ગયા. Okay, that means કે આપણી જોડે sin x cos x both are continuous function, so that its summation, multiplication as well as subtraction is a continuous function. Okay, exercise 5.1 23 number no example. Find all the point of discontinuity of f where f of x is equal to sin x upon x where x less than 0 and x plus 1 where x greater than equal to 0. Okay, you have to find which point given function is discontinuous. Okay, so first of all, for x less than, all the value of x less than 0, given function is equal to same. Okay, same function given, so that we can say that same to same for all the value of x greater than 0, function will be same, so that we can directly say that f is continuous at x less than 0 as well as x greater than 0. Okay, so you have to check at x is equal to 0 whether function is continuous or not. Okay, so left hand side limit x tends to 0 minus f of x slightly less than 0, slightly less than 0, function will give sin x upon x, that means the limit x tends to 0 minus sin x upon x, answer will be 1. Directly it is a formula of limit. Okay, 11 standard, remember. Okay, next limit x tends to 0 plus f of x slightly greater than 0. Okay, that means slightly greater than 0, function will gives answer x plus 1. So that limit x tends to 0 plus x plus 1 gives okay, directly put the x is equal to 0, 0 plus 1, directly answer 1, as well as f of 0, 0 plus 1, answer 1. So that limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x is equal to f of 0. So we can say that f is continuous at x is equal to 0. Okay, so લખી શકાય at any point. Okay, that means કે there is a no point of discontinuity. That means કે that any point no point at that function, given function is discontinuous. Okay, 24 number example. Determine if f is defined by f of x is equal to x square sin 1 upon x, where x is not equal to 0, and 0 where x is equal to 0. Okay, is continuous function. Okay, continuous function, first of all, x is not equal to 0. That means for x less than 0 as well as for x greater than 0, function will give answer same to same, x square sin 1 upon x. So that we can directly say that f is continuous at x less than 0 as well as x greater than 0. Okay, at x is equal to 0, we have to find the limit x tends to 0, f of x is equal to f of 0. So we can say that f is a continuous function. Okay, let us check. Limit x tends to 0, f of x is equal to limit x tends to 0 sin x square sin 1 upon x. Okay, હવે આની વેલ્યુ ફાઇન્ડ કરવી હોય આપણે તો યુઝિંગ ઇનઇક્વાલિટી પરથી 11th સ્ટાન્ડર્ડમાં તમારે જોડે આવતું સેન્ડવિચ થિયરમ. ઓકે, so for example, range of sin function any angle, that means ke minus 1 to 1, that means ke minus 1 less than equal to sin 1 upon x less than equal to 1. Okay, whole inequality ने x square वडे multiply करे, that means के minus x square is less than equal to x square sin 1 upon x less than equal to x square. Okay, and all the inequality you have to put the limit. Okay, that means के limit x tends to 0, all inequality limit x tends to 0, minus x square is less than equal to limit x tends to 0, x square sin 1 upon x, and less than equal to limit x tends to 0, x square. Okay, sandwich theorem says that if left hand side limit and right hand side limit gives the same answer, okay, then middle inequality માં middle term જે આવે એનો answer same to same હશે. That means કે limit x tends to 0 minus x square is equal to limit x tends to 0 x square gives same answer is equal to 0. So that we can say that limit x tends to 0, x square sin 1 upon x is equal to 0 according to sandwich theorem. Okay, and 0, f of 0 will gives also 0 answer. So that limit x tends to 0, x square sin 1 upon x is equal to f of 0. So we can say that at x is equal to 0, function will f is continuous at x is equal to 0. So that given function is continuous function. Okay, exercise 5.1, 25 number example. Examine the continuity of f where f is defined by f of x is equal to sin x minus cos x, where x is not equal to 0, and minus 1 where x is equal to 0. Okay, so first of all you have to know that for x is not equal to 0, that means x for a value of x greater than 0 and as well as x less than 0, function will be same. So that function is continuous at x greater than 0 as well as less than 0. Okay, then you have to check at x is equal to 0, given function is continuous or not. So that limit x tends to 0, f of x is equal to limit x tends to 0, f of x, that means ke sin x minus cos x. Okay, put the value of x is equal to 0. So that sin 0 minus cos 0, so that 0 minus 1, answer will be minus 1, as well as f of 0 given minus 1. So that limit x tends to 0, f of x is equal to f of 0, and f is continuous at x is equal to 0. Okay, that means ke x is for x is equal to 0, function is continuous, as well as less than value, greater than value, function is continuous. So that we can say that f is continuous at x belongs to R. Okay, તો આ આપણે એક્સરસાઇઝ ના અમુક એક્ઝામ્પલ કમ્પ્લીટ કરીએ. ધેન થિયોરમ નંબર 2 પર આવીએ. થિયોરમ નંબર 2. ઓકે, સપોઝ f and g are real valued functions such that FOG, composition function, f composition of g, okay, is defined at c. If g is continuous at c and f is continuous at g of c, then FOG is continuous at c. That means f and g both are composition function and f continuous as well as g continuous, then and then we can say that f of g is continuous function. Okay, for example, example number 19 complete કરીએ આપણે. Example number 19 શું કહે છે? So that the function defined by f of x is equal to sine of x square is continuous function. Okay, so that the function defined by f of x is equal to sine x square is continuous function. Let for any real number આપણે પાર્ટીશન કરી દઈએ, g of x is equal to sin x and h of x is equal to x square. Okay, is continuous function. Okay, that means that these are the composition function. One is trigonometric, outer function is trigonometric function and inner function is x square. That means that polynomial function. So that we can say that g of x is equal to sin x and h of x is equal to x square is continuous function, because these are trigonometric function. All trigonometric function are continuous function as well as x square. That means polynomial function also continuous function. So that we can directly say that these are the continuous function. Okay, so that f of x is equal to nothing but g composition of h of x. That means g of h of x is equal to g of x square and another is sin x square. That means it is a f of x. That means g continuous, h continuous. That means g composition h continuous function, as well as we can say that f is continuous function from theorem 2. Okay. Okay, 5.131. Okay, show that function defined by f of x is equal to cos x square is continuous function. Again, illustration example number 19, same. Okay, for every real function, okay, g of x is equal to cos x and h of x is equal to x square, because f is a combine of these two functions. That means the composition function of these two, cos x and x square. Okay, it's continuous function because f is composition of g and h, because g composition h of x is equal to g of h of x. H of x consider x square. That means g of x square and cos x square, because here cos x and x square both are continuous function according to theorem 2. Okay, we can say that f is continuous function. Same as 32 and 33. Same to same question છે આપણી જોડે. That means કે you have to do it yourself. Okay, that means કે homework 32 and 33. 34 IMP example છે આપણી જોડે. Here find all the points of discontinuity of f defined by f of x is equal to modulus x minus modulus x plus 1. First of all, you have to neglect these two modulus form. Okay, that means ke removing these two modulus form and convert into function. Okay, because here modulus x gives minus x where x less than 0 and plus x greater than equal to 0. Okay, separately આપણે જોઈએ modulus x plus 1 gives minus of x plus 1 where x less than minus 1 and plus x plus 1 where x greater than 1. So that here we can get three values. Okay, 0, minus 1 and 1. Okay, so first of all you have to check what is the answer if x is less than or equal to less than minus 1. Okay, second portion, what is the answer if value of x in between minus 1 to 0. What is the value if x greater than 0. Okay, that means you have to consider three cases. For x less than minus 1, for x less than minus 1, modulus x is converted to negative. That means minus x, and modulus of x plus 1 is also negative value. That means negative negative positive, because in between these two here negative sign. So that minus x plus x plus 1, minus x plus x cancel, answer is equal to 1. For x less than minus 1 always gives answer 1, first form. Second portion, if value of x in between minus 1 to 0, okay, consider as a minus 1 in between. Okay, that means f of x in between, that means શું લખાશે modulus x converted to minus x and x less than 0. That means શું લખાશે આપણી જો modulus of x minus 1, sorry, x plus 1 is also positive value. Okay, that means minus x plus 1. So that minus x and bracket open करिए minus 1 तो -2x -1 second portion. And for x greater than or equal to 0, okay, both positive value, both gives positive value, that means x and x plus 1, so that x in between minus x plus 1, x minus 1, that means answer is equal to -1. So that for x greater than is equal to 0 always gives answer -1. So we create a function if 1 where x less than -1, -2x -1 if -1 less than equal to x less than 0, and -1 if x greater than equal to 0. Okay, then f of x is equal to 1 where x less than -1, 2x -1 less than equal to x less than 0, and -1 where x greater than equal to 0. Okay, directly we can say that for all the value of x less than -1 as well as x greater than 0, for function f is continuous function. Okay, because same to same answer given. Okay, you have to check at x is equal to -1 as well as x is equal to 0 whether function is continuous or not. For x at x is equal to -1, limit x tends to -1 minus f of x is equal to slightly less than -1, and answer is equal to 1. And limit x tends to -1 plus slightly greater than -1, function is -2x -1. Okay, and directly -2 instead of x you have to give one -1, that means -2 -1 into -1, that means the answer is equal to 2 -1, answer will be 1. And f of -1, directly this function similar, -2x -1, putting the value of x instead of -1 instead of x, so that answer is equal to 1. So that limit x tends to -1 minus f of x is equal to limit x tends to -1 plus f of x is equal to f of -1. So that f is continuous at x is equal to -1. Similarly, at x is equal to 0, left hand side limit x tends to 0 minus f of x is equal to limit x tends to 0 minus less than 0, so that -2x -1, and answer will be a -1. Same, limit x tends to 0 plus slightly greater than 0, and answer will be -1, and f of 0 also -1, so that we can say that limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x is equal to f of 0, so that f is continuous function at x is equal to 0, so that there is a no point of discontinuity. Okay, and similarly example number 20 as your homework. Okay, તો અહીંયા આપણી જોડે exercise 5.1 complete થઈ જશે.